everyone. Okay, it's 1.3 time, so let's get at it. We can do it. Okay, section 1.3 is the multiplication property of equality. So in section 1.2 we learned about adding to both sides, and in section 1.3 we're going to learn about solving equations by using multiplication to both sides, and also by using multiplication's best friend as well. And so they're saying if you started off with this true statement, then you could multiply by c both sides as long as c is not 0. If c is 0, then you can't do it. And that's a lot of how sometimes people say, I was solving this crazy equation. It's going to be beyond us, and they didn't realize that they were multiplying by 0. And that's what makes it not true. And so that's not going to happen to us right now, but it is going to happen in the future. And so I'll be reminding you of this point. And so for right now, we won't worry about it. And the multiplying both sides of the equation by the same non-zero number will not change the solution set. So the solution set to this and this will be the same. And I remind you that, hey, your book says there's 2 properties, but I kind of say there's 4 here, because division is defined as multiplication by the reciprocal. Multiplying both sides of an equation by the same number is equivalent to dividing, right? Diving, D-I-V. How do you spell dividing? D-I-V-I-D-I-N-G, right? I don't know, that wasn't looking too right. And so if you started off with A equals B, that's the same as dividing both sides by C. B divided by C. As long as C is not 0. You're not allowed to divide by 0, and when you're solving an equation, you don't want to multiply by 0. It doesn't turn out to be a problem. So we're going to give a try to this. What you do to one side, you got to do to the other, whether it's add, subtract, multiply, or divide. And so we'll get rid of all these flex. Start looking like negative signs if we're not careful. My erasing flex. And so this is problem 6. Negative 6x equals 2. So this side is as simple as it gets. And that side is as simple as it gets. So that would be the first thing that you would do, is simplify both sides. But they're as simple as they get. And it wouldn't help to add 6 to that to get it away from the x, because it's not x take away 6. What it is, it's negative 6 times x. This is multiply. Negative 6 multiplied by x. So if I want to get rid of the negative 6 so that I can leave x by itself, right? If I want to get rid of the negative 6 so that I can leave x by itself, what I have to do is I have to unmultiply it, which is divide. And so what I have to do on this side, so I have negative 6x. On this side, I have to divide by negative 6. And what that makes is negative 6 divided by negative 6, which is 1x on that side, which is x, which was my goal, was to leave x by itself. And I'm undoing that multiplication with a division. Now, what you do to one side, you got to do the other. So the other side you had 2, right? And so you have to also divide it by negative 6. So, and this was in my thoughts, right, that I got 1x, which is x. And that's what I wanted. I want to leave x by itself. That's how I solve the equation. And so now I have 2 divided by negative 6. And if you reduce that, that is 1 over negative 3, you might write. But that's the same as writing, that's the same as writing that negative out to the side, right? So I can write it like that, or I can write negative 1/3. Because having 1 over negative 3 is equivalent to negative 1/3. Remember, we've been talking about that. These are equal to one another. And this is the conventional way of writing it, as negative 1/3, as opposed to 1 over negative 3. And mathematics has a lot of conventions. A lot of areas have a lot of conventions, right? English has a lot of conventions, definitely. And then I want to check my answer. So I have negative 6 times x, and I'm going to put the parentheses right where x is, equals 2. and I'm going to plug into my parentheses what I said x is, which is negative 1/3. And then my choice, whether I use my head or my calculator to do that. And I've been kind of practicing with my calculator a little bit. So -6, and then the parentheses, and then a negative, and then the fraction 1/3. And I get, I hope, 2, and I did 2 equals 2. So what if you put in the calculator, instead of putting the negative there, what if you put the negative downstairs with the 3 right there? Yeah, you would get 2 as well. And so that these are the same is what makes me have the right answer. If those were not the same, then it wouldn't be that there was no solution. It would be that I have made a mistake, is what it would be. And so, so that's kind of the story there. And then this is one that quite often people will tell me that there's no solution on. But I bet if you just started thinking about what x is, 7 times x equals 0. What is x? It's not no solution, right? You can think of something that's the answer. And so, and often it'll come up, you know, like you worked a whole bunch of work and then you'll get to this point and then people will put no solution. And so anyway, so I think that's why I wanted to make sure that we practiced it. But if I want to leave x by itself, that's as simple as it gets, 7x. And that's as simple as that gets over there, 0. So if I want to leave x by itself, well, what's happening with x? Well, it's being multiplied by 7. So I want to undo the multiply by doing a division. So I'll divide by 7. I'll divide by 7. Both sides. 7 divided by 7 is 1. And 1x is x. And 0 divided by 7 is 0. And if you're not trusting yourself, if you're saying, wait a minute, was it undefined or was it 0? Well, you can put it in your calculator and check. Does your calculator know? And the answer is yes, it does. So 0 divided by 7 is 0. So the calculator does know. Same as this one up here. If you were, I did that in my head. If you were like, well, could I done it in the calculator? And the answer is yes, I could do this fraction. 2 over negative, oops, I was pushing the negative key and I pushed the fraction key instead. -6, right? Hit equals and it says negative 1/3, which I had got. And so anyway, so that's good. And this one is kind of silly to check because 7 times what is 0? And we're saying the answer is 0. And 7 times 0 is 0. So we knew that was going to work. Okay, so we did a lovely job on it. Then they start talking about problems that have more than one step. And they tell us that, well, there's a strategy when you have more than one step. And I've been saying that you need to simplify one side at a time. And that's really those 2 steps. Simplify the left, simplify the right. So if there's any distributive property, you go do it. If there are any like terms to combine, you go combine them on the left side and the right side. And what you're essentially doing is you're simplifying the left and you're simplifying the right. So LHS does not stand for Liberty High School. And RHS doesn't stand for Ridgeview High School. That stands for left-hand side of the equation. So I want to look at the left-hand side and make sure that it is as simplified as it can go. And in this case, it is. There's no parentheses there for me to distribute, right? There are no like terms to combine because this is a variable term and this is a number term, and they're not like terms. And then on the other side, on the right-hand side, I just have a number. So my goal is to use the addition and subtraction property with the goal to get the variable term on one side and the number on the other. And I don't have that done right now, like I did in the last problem we did, right? In the last problem I did, if I said I want to get the variable on one side and the number on the other, well, it's done. -6x is a variable and 2 is a number, and they're separated. and 7x is a variable and 0 is a number. They're separated, variable on one side, number on the other, and it doesn't matter which side you have the number and which side you have the variable. So here I have the variable on the left, but if you put the variable on the right, it would have been just the same. It doesn't matter. Mostly people like to put the variable on the left, so I would say that 90% of the problems that you encounter from the textbook have the variable on the left. But it would not be wrong to put it on the right. Okay, so, but that's not the case here, right? That doesn't have just the variable on the left side. It has a variable term and a number term. So what I want to do is I want to get it so that it has just the variable on the left-hand side, and I'm going to put the number on the right-hand side. So of equals, right? So this is the left of equals and the right of equals. So this right here, I want to make it so that this is just a variable. And right now, it's a variable and a number. And then I want to make this over there so that it's just a number. And I'm like, well, hot diggity dog, it's already just a number. And so what I'm going to have to use is, it says, my addition or my subtraction property or principle so that I can make that true. And so if I want to leave the variable there, well, that's the variable term, so don't do anything to it, but look at what's happening with the term that we called the number. It's adding to that variable term. So I need to undo the add by doing a subtract of half. So I want to leave that alone, and I want to remove this so that all I have is a variable. I'm making this into 0 so that I have the variable plus 0, or the variable minus 0 if you want, which is just the variable. And then what you do to one side, you got to do to the other. So I took away half. Half is a number. This is a number, so I'm going to take away half. And whether you're a person that writes it out stacked like I do, or if you write it like this, if you write it like this, I can see where that's kind of nice because that's how I'm going to put it in my calculator. I like to stack it, but I don't know. I might be convinced, right? So this is 2/3 x on this side equals, and then it is what it is. So I'm going to put it in my calculator and figure out what it is, or whip out your common denominator of 4 and do it in your head. Your choice. It doesn't matter to me which one that you do. So when the dust clears, I get negative, I did it in my calculator, and I got negative 5/4. And then, so now I have made it look like these did by using the addition. I added half, right? I have a variable term equals a number, just like I have here. A variable term equals a number. So that's when you know that you're ready to go on to the next step. 2/3, is that T or I? Or I think that my printer, I think this was a T. And I think that when you guys have your version of it, and I think my printer is almost out of ink, as you guys can see. You can see where my printer right here is a little bit out of ink, and somebody needs to go to Costco quickly before I print too many more of these, because it's starting to, and I think that's what happened, is that it kind of drug, I think. And you see here how it's a number and then a variable on the other side. They're separated. A variable on one side, a number on the other side. They're separated. This one's actually done because you want to get just the variable all by itself, totally isolated. And so this one, the variable's not completely by itself because it's the 2 times y and the 2/3 t and the 3x. This is going to have to become 2 videos because my cookies are here. And so I'm going to stop and do a part 2.